So, sensible heat gain, that infiltration 1 comes out to be 245. So, your total is 33,270, right, 270 watts, and latent heat we have seen
4,000.
Yeah. So, Q, this is Q, we call it QS, and QL is equals to 4,000 watts. Next step, I want to find out the mass flow rate, right, mass flow rate. So, this must be the heat removed, sensible, whichever is higher we take that. This is usually much higher. So, this much watt. So, sensible heat to be removed is this, and if my mass flow rate of supply air, let us say is m into specific heat into delta T, that will be the mass, specific heat into delta T, that is the amount of heat it will remove. So, we can now, what we do is we can find out the, because temperature differential we have already said that we will keep it at 10 degree, we will keep it at 10 degree. So, specific heat is known to us, m we can find out, specific heat is known to us. So, let us calculate this out, let us calculate this out. So, therefore, we take it to be QL, Q, we are taking the here, keeping is there, right. So, 33,270 must be equals to mass flow rate, combined mass flow rate, fresh air and recirculated air, because finally that is the total air. So, multiplied by Cp into that's delta T, let me call it, and we have decided that we will keep it at 10, and m and Cp is 1010 into 10. So, you can now find out what is the m, 3.3 kg per second. This comes out to be 3.3. So, this comes out to be, so if you divide by this 1010101010 that is right, because that will be equals to your m. So, that will be equals to your m. So, m will be equals to this, and right, m will be equals to, and this comes out to be 3.3 whatever it is, right. So, that is your mass flow rate. Now, out of which you require minimum fresh air supply, right, for hygienic requirement, and that is given as 0.01 cubic meter per person, that is given in the problem, that is given in the problem. For hygienic requirement, there are some value is given, 0.01 cubic meter per person. So, if I have 100 persons, then this will be 0.01 multiplied by 100, that much cubic meter per second, actually, I mean cubic meter, this per hour or per second it is given. Fresh air required was coming, fresh air required is 0.1 meter cube per 1 meter cube multiplied by 1.2 divided by 293 into multiplied by 293, 3 divided by 298. That, yeah.
308. It was 35 degrees.
Yeah, 308. So, 308. So, you can find out this comes out to be 1.16. So, 1.16 kg per second is a fresh air. Let me just write it now, all sum it up and clearly write it. So, total mass flow rate is 3.3 kg per second. Fresh air flow rate 1.16 kg per second. So, then remaining is recirculated air. So, recirculated air will be 2.14 kg per second. Recirculated air will be this much. Now, one thing still remains to be found out, the moisture content of the supply air. Moisture content of the supply air, and also the amount of cooling that I want to do, because 25 degrees centigrade I am maintaining. No, there is a mistake. Supply air temperature is 15 actually, room temperature is 25, supply air temperature is 15, because 10 degree differential I will keep it, all right. So, for calculation wise I think there was no problem, because 35 degrees is the outside temperature we have calculated based on this. I think we did not make any mistake so far, but supply air temperature would be 15 degree, and corresponding moisture content we would like to find out, and how much is the cooling required, actual cooling, maybe the energy required would be somewhat different, because the efficiency etc. will come in. So, first two steps we have done is we have found out the right. Now, this is the recirculated air and this is the fresh air required, total air is 3.0. What will be the temperature of this air? What is the temperature of this air? That I can find out. How can I find out what will be the temperature of this air? It would be some 2.14 into, this is recirculate 25, 2.14 into 25 plus 1.16 into, okay, let me just do this calculation. So, erase this. So, we have seen that 2.14 and 16 total. So, mixture temperature of the mixed air, T of the mixture T temperature of mixed air. I have now recirculated air and fresh air, I have mixed them together, and would be given by, say, let me call it T m, right. This would be how much? This would be 2. How much was it? 2.14 into what is the temperature of the recirculated 25 degrees centigrade, plus fresh air is 1.16 into 35 divided by 3.3, because it is simply linear relationship. So, law of mixture. So, that you can find out what is the mixture temperature. Mixture temperature will be how much it is. Mixture temperature will be somewhere in between the two, 25 and 28.5. So, that is the mixture temperature. Now, I also want to find out the moisture content of the mixture. For that I have to go to the first I have to go to the, because moisture content of the outside air is known to me. How? From psychrometric chart. If I have a psychrometric chart, quickly I will show you, because in psychrometric chart you have got dry bulb temperature here, and what is given? Wet bulb temperature. So, wet bulb temperature lines are given like this, wet bulb temperature lines are given like this. So, look at the dry bulb temperature and your wet bulb temperature, the moisture content is here, right. This is absolute moisture content. In this case our temperatures are given 25 and some relative wet bulb temperature is given 12 or something. So, you look at 12 and find out what is the moisture content. So, this one it may not have, this one may not have, anyway you can complete this problem, I am just telling you the procedure. So, basically then you find out the wet bulb moisture, basically moisture content you can find out from psychrometric charts. So, temperature of the mixture we have found out, we will keep this in record for a while, or erase everything in a way, erase. So, temperature of the mixture we have seen that T m is equals to 28.5. G of the supply, G of the mixture I have to find out, but first G room, moisture content of the room will correspond to dBT 25 degrees centigrade dBT, and how much is the wet bulb temperature is given, or
4 degrees Celsius outside wet bulb temperature.
no, inside 60% relative humidity, something like that. Room should be the average U value is given, the radiation is given, the inside relative humidity is 60%, inside relative humidity is 60%, right, is given, right, inside 35, outside temperature is, inside relative humidity is, outside WBT is 24. So, G room, if you want to find out, you have to go to the psychrometric chart, look for the 60% curve, relative humidity 60% curve, 25 degrees centigrade, and then from this curve extend this horizontal point, this will be the absolute humidity or moisture content, H or G. You will get the G room from this for 25 and 60. So, if you look at psychrometric chart, this you can find out. Right. Similarly, for outside what is given? Outside is given 35 degree and WBT is 24. So, in case of outside you go here, outside you can go here, outside somewhere 35 and WBT line of 24 you check, this will cut somewhere here and you come here, you get the G outside, G outside. So, this you have to find out from the chart. Did you find it out from the chart? Quickly. There would be order would be very small, 00 something, 007 and 07 and so on, something of that kind, or 0014 and things like that. So, you can find out that. Now, if you want, if you have, once you have found out that G outside and GR, G outside and GR, then you can find out G of the mixture by similar formula. G of the mixture by similar formula, right? G of the mixture by similar formula, right? Okay, but I'll give you the equations now. Obviously, I'll not do the I'll give you the equations. Next slides actually gives you the equation for calculating relative humidity values. Next slide, set of slides gives you, because chart is one thing, but today hardly anybody uses chart, or put it in an Excel sheet and get it straight away. So, G of the mixture will be given as G of the mixture will be given as G room multiplied by 2.14 plus G outside into 1.16 divided by 3.3, because 2.14 is a recirculated air and its room moisture content is Gr. So, it is again law of mixture. So, once I mix, I will get something in between. So, G of the outside so multiplied by 1.16. So, I am mixing 1.16 kg per second with 2.14 kg per second. What will be the, if I mix the two air or different moisture content will be the average moisture content per unit mass, per kg of air, if I calculate out, this is the average. So, divide by 3.3 kg per second, which was the overall mass flow rate, you will get the moisture content of the mixture, So, you have got Tm, you get Gm. So, Gm value is how much? Any idea? Gm value coming out to be, how much is the Gm value? Once we have found out this Gm value, mixture temperature I have found out. But then I have to cool it to a lower temperature, right? I have cool it to a lower temperature, to remove the amount of heat. So, any idea about the value Gm? Okay, it's okay, doesn't matter. So, you will have to see the chart and you complete this process. Yeah, chart. So, you have to find out from the chart. So, once you have found out from the chart, you have found out the moisture content of the mixture. Now, I got to actually this same air. First of all, I have to see whether what is the like supply air temperature we have decided, that should be 10 degree lower than the this mixture. I will have to cool it to 15 degrees centigrade. This mixture has got now a temperature of 28.5 and 15 degree centigrade. Now, the moisture content of the supply air, that I can find out from latent heat removal, because I want to remove 4000 watts of latent heat. Room moisture content is known to me. This this must be equals to L, the latent heat of evaporation, which was 2501 kilojoules per kg, multiplied by the mass flow rate I know, that will be 3.3 into Gr minus Gs, into Gr minus Gs. So, supply air. So, this I can find out from this equation now. L is known to me, 3.3 is given because that is the supply rate, Gr I have found out. So, Gr minus Gs I can find out, Gr minus Gs I can find out. So, supply air temperature that is entering into the room will be at 15 degrees centigrade. The moisture content must be given by Gs. Now, if there is some loss in the loss in the pipes etc., you might take that into account, and actual temperature, how much loss is possible, percentage loss, that you can find out, and from that you can decide on how much temperature, temperature of the actual cooling, how much up to what temperature it should be done, up to actual cooling should be done up to what temperature. Now, if you know the temperature of the the 15 degree, we said maybe it comes over to 13 or 12. So, this mixture at 28.5 at 3.3 kg per meter second, kg per second, and the moisture content of Gs, this should be brought to now 15 degree or slightly less, whatever. Now, let us say for our class, let us take it to be 15 degree because we said 10 degree differential and loss, let us we neglect that. So, you will have to bring it to 15 degree, and how much enthalpy change corresponding to that, that I should find it out. If you 3.3, so specific enthalpy is given, you remember I gave you a formula earlier some class. So, specific enthalpy is given as, that is right, this Cp into T plus L into Gs moisture content, because we said all evaporation will take place at 0 degree centigrade, plus L plus Cw, L plus Cw into Gs, L plus Cw, specific heat of water. So, these values are given to me. What is the enthalpy of the supply air? If it is at 15 degree, I can calculate out specific enthalpy of supply air, that would be corresponding to 15 degree and Gs. So, specific enthalpy corresponding to, so H corresponding to 15 degree and Gs I can calculate out, and H corresponding to H corresponding to mixture, that I can calculate out because it is at 28.5 and G of the mixture is known to me. This difference is the amount of cooling I or heat, internal heat change I require in the air, right, internal heat change I require for the air for unit mass. This multiplied by, so m multiplied by m dot multiplied by Hs minus Hm, that is actually the energy that I got to remove, or I got to basically I have to cool it to that level. So, that much of energy I got to remove. This is the cooling load. This is the cooling load. This is the cooling load. So, this is the cooling load, but this is the cooling I am doing. The refrigerator will do much more work. The amount of work required for the refrigerator to do this work, that I am not interested in, but this will be the cooling load finally, because that will depend upon the machine system, mechanical system that is there. So, I think that that ends up our discussion on this problem itself, right. So, that is how we find it out. Now, I have not done full calculation, I leave it for you to do the rest of the calculation, look at the psychrometric chart or use the equation to find them out, right, use the equation to find them out. So, let us look at the equation then, let us look at those equations then, if rather than psychrometric chart is there. So, the equations, if you look at it, dry bulb temperature we measure, this course I am just repeating this, we do this in some other course. Temperature we measure in Stevenson screen, dry bulb temperature is measured, if you have seen outside temperature will be measured kind of there is a box which will have louvers, so that air movement is not there. So, it is a calm air, so we measure, this is called dry bulb temperature. And we know the partial pressure or pressure would be given as part of the dry air pressure plus moisture vapor pressure. Total pressure is the sum total of partial pressures. Now, what is partial pressure? Partial pressure is the pressure of the gas when it occupies the same volume as the mixture. If you have a container, I hope I have a diagram. No, I don't have a diagram here. Supposing I have a container and I fill in one gas there, some mass of the gas, it will exert some pressure. Now I fill in another gas, some mass of another gas, it will exert some pressure. If you mix these two masses together and put it in the same container, pressure will now increase. This pressure is the sum total of those pressures, individual pressures. Individual pressures are called partial pressures, right. When you have put the mass into that volume, you got some pressure, that is the partial pressure of that gas, and when you put the another one is the partial. So, if you have water, vapor and dry air, which is again a mixture, but we are not going to that, argon, etc., carbon dioxide and oxygen, nitrogen I told you. So, the sum total, this is the moisture vapor pressure plus the pressure of the dry air is the total pressure. So, sum total of the partial pressure will give you the pressure, and I can now apply ideal gas law. So, if it is only one gas, then Pa Va into mass of that gas divided with the molecular weight into RT. They are at same temperature, let us say. Then similarly for the vapor, Pv Vv, volume of the vapor is equal to mass of the vapor, molecular weight of the vapor into R into Tb. Now, Tb and T temperatures are same, Tb and T temperatures are same because we are dealing with the same temperature. Then the moisture content we define as mass of the moisture vapor divided by mass of the air. So, this can be written as, from this it follows, mass of the vapor divided by the mass of the air. Only thing that is, Ba and Bb will be same because we are talking of the same volume terms. So, these are same, R is same, temperature is same. Only thing that is different is Mb and P. So, I put it in Mb by Ma, I can write it in Pb by Pa, doing little bit of algebra, and that comes out to be 0.622 partial pressure of vapor divided by pressure of dry air. And Pb is nothing but P0 atmospheric pressure minus vapor pressure. So, you see, you can calculate out the moisture content in terms of partial pressure themselves, provided you know partial pressures, right. So, psychrometric chart therefore gives you partial pressures also corresponding to moisture content, you get partial pressures also, right. Okay. Relative humidity, how it is related? G by saturated Gs, G by saturated Gs, that is by definition. And now we have some empirical formula to calculate out the relative humidity, right. So, partial vapor pressure of the vapor is given as saturation vapor pressure minus some constant into atmospheric pressure T minus T wet bulb temperature. So, if you know wet bulb temperature, you should be able to calculate out the partial pressure from such an empirical formula. The values of C1, atmospheric pressure, if it will depend upon what unit you are taking. Supposing you take it in 1 atmosphere, then this value is 1. So, you can find out in this manner, and PSB is given, PSB is given this value, saturation is given in terms of this kind of an empirical equation. And saturation, yes, P. So, at any moisture content, the saturation vapor pressure is given by this formula. This formula, like empirical formula like this, maybe we should calculate out. PSB is the saturated vapor pressure in bar in WBT, at WBT, and PS is the saturated vapor pressure in bar. 1 bar is 1 atmosphere, or P0 is 1.103 bar, it is taken nearly 1. So, at dBT. So, PSB is the saturation vapor pressure at the WBT, and PS is the saturation vapor pressure at dry bulb temperature. So, G, now you have got PV, you can calculate out, because if you know the wet bulb temperature, you should be able to calculate out PSB first and then PV, and G is basically 0.622 PV divided by P0 minus PV. So, you can actually calculate out GS from this empirical equation right, Gs from this. So, G from this empirical equation, and Gs you can find out. Instead of using Tw, if you use T, then you get Ps.
So in that question, relative humidity was given to us.
Yeah. So, if it is relative humidity is given, yeah, that is right, relative humidity is given, then straight away you can find out, because saturation humidity you need. So, you can find out moisture content corresponding to that, and if it is wet bulb temperature is given, you can then also find out, right. So, such only thing that you have to find out is at 100%, like for the dry bulb temperature, what is the saturation. So, using this equation you can find out the relative humidity value rather than going to the psychrometric chart. You can try this out. The psychrometric chart is also here anyway, is there, right, sorry, psychrometric chart. So, if you look at it, I am just repeating the psychrometric chart, earlier I showed you, right. So, if I repeat it, this is the dry bulb temperature, these are the relative humidities, and wet bulb temperature, inclined ones, enthalpy lines are also there. So, we need not look into the enthalpy line, we can straight away calculate from the formula, and if you know that relative humidity, let us say 60% somewhere there, 60% somewhere there, right. If you know relative humidity 90, 80, 70, 60, 60% relative humidity, and how much was 25 degrees centigrade. So, go there, go here, you will get the absolute humidity, moisture content you will get. Something like 0.0014 or some such thing it comes out to be, and you can calculate some formula also. And if it is wet bulb temperature at 35 is given, 24 degree wet bulb temperature you can take, and corresponding moisture content you can find out. It might be higher or lower depending upon the situation. If it is higher, okay, whatever the value is, if it is higher, and finally then you have to do that condensation. So, you have to see how much moisture you got to remove corresponding to that, what is the dry bulb temperature, the dew point. So, corresponding to that you will find out, but I think in this problem I did not complicate this issue. So, that is how you can find out, right. So, that is how you can find out, okay, this I think at the moment I think I may not look into, next class we might look into. So, you can actually wet bulb depression can be related to all this, dew point temperature can be related, because if you have to do cooling beyond dew point, you might have to go to this temperature. So, this anyway we will see later on, we will see later on in the next class. So, at the moment if you have some questions, I think I will be able to answer. So, the problem you can do the rest of the problem yourself, either might use the equation or might use the psychrometric chart, whichever way you like, and complete this part.